Last step, the pH after adding 5.0 milliliters of base beyond the equivalence point. Alright, how to do this? Well, you already get the conjugated base at the weak base at equivalence point. Then you add another 5 mL of excess, actual strong base. You have a mixture of the strong base and the weak base. In fact, the contribution of hydroxide from the weak base in this case can be neglectable. Well, we'll first calculate the concentrations. If you really want, you can really write the S table to make sure or to double check how small the contribution of hydroxide is from the conjugated base. How to do this step? Step F, 5 mL excess. 5 mL times the concentration, 125 molarity, give us, okay, now this one I do not need a calculator, 0.2625 millimole. I like this unit instead of mole. Milli means 10 to the negative third power. If you use milliliter times molarity, you get millimole. If you liter times molarity, you get moles. So that's the moles of the excess strong base. In this solution, you also have 2.10, let's say, millimoles of sodium A as a weak base. Okay, you have a small amount of strong base and a little bit more, like say, probably 3 times more, a little bit more than 3 times more amount of a weak base in the solution. What's the total volume? The total volume, well, you start from 20, you add equivalence volume 16.8, then you have another 5 milliliters. What's the total? Okay, just do this by hand, by heart. 41.8 milliliters. Then what will be the concentration? If you want the concentration for sodium hydroxide at this condition equals 0.625 millimole divided by the total volume, which is 41.8 milliliter. Now you need a calculator. That's a simple division. First clear them, 0.625 divided by 41.8 give you, okay, 0.0150. 0.0150 molar. How about the sodium A, the weak base? In real calculation, you do not really need this, but you can say 2.1 divided by 41.8 give you 502. 0.0502 molar, 502. In fact, the contribution from the weak acid is neglectable. All the hydronium is from sodium hydroxide, whose concentration is 0.015 molar. So it's completely dissociated, 100%, 0.015. That would be the hydronium concentration. The equilibrium hydronium concentration supposedly equals 0.0150 molar. So POH equals, take the negative logarithm, just say logarithm, 1.82. POH equals 1.82. Then the pH, well, it's 14 minus 1.82. If you really want, 14 minus 1.82 give you 12.18. That would be the answer. If you really want to find out, okay, what would be the constant, how much the sodium acetate, sodium A, will contribute to the total concentration of hydroxide, take a look of this S table. A plus water give you HA, HA plus hydroxide. I omit the aqueous sign just to make the writing a little bit short. ICE, then here, what would this be? The concentration, completely dissociate 0.0502, not a small number. But the hydroxide is from sodium hydroxide. It's also completely dissociate 0.050. Let's say this is 0 at beginning. Change, let's say y, that's y, negative y, equilibrium 0.0502 minus y, and 0.0150. Let's assume the contribution of y is small, assume it's small. Then you have the Kb equals the hydroxide concentration, OH, times A minus over OH. That's A minus, so this HA, A minus, that's a Kb, well, equals 0.015, assuming y is small, multiplied by y, divided by 0.0502. Well, you solve for y equals 0.0502 over 0.0150 times 5.6 times 10 to the negative 10th power. You probably got 1.7 times 10 to the negative 9. Let's try to see if my estimation is correct. 0.0502. Oops. 0.0502 divided by 0.0150. Okay. Multiplied by 5.6 exp negative 10th power give you 1.8 times 10 to the negative 9th power. And I got 1.7. It's close to 1.9. Let's change to 1.9. 1.9 times the negative 9th power. So this y compare with 0.0150 is really small, negative 9th power. So the contribution from the weak base sodium A is very, very small. You don't really have to worry about this. It is neglectable. So a mixture of the strong acid with a weak acid or strong base with a weak base, you only have to consider the contribution from the strong acid in most of the case.